We would like to present some problems with the late Paleolithic ornamentation which could be solved due to experimental research. Our example is an ornamented artifact from Birów. The artifact was discovered at Podzamcze, in cave number 4, at the foot of the Birów mountain in the Polish Jurassic highland in South Poland. The ornamented antler fragment rested inside the upper level of layer 5. Its exact location was not recorded. The bone assemblages are typical for the so-called mammoth steppe. They represented mostly reindeer. The lithic assemblage from layer 5, 47 flint artifacts dated to the Paleolithic, was identified as orination. The fragment of reindeer antler fractured at both ends. The radiocarbon date of the object corresponds to the transition from the Alerod to Younger Dryas, the Fedemese culture. In our research, we use different microscopes from our laboratory for archaeological conservation and archaeometry, and a CT scanner at the Wrocław University of Science and Technology. The antler is fissured and its surface is now abraded and eroded by chemical and mechanical factors. The fragment was formed using the groove and splinter technique. The ornament is engraved in the compacta. The ornament is composed of 6 rows of dots. The dots are now abraded and eroded by natural factors. At the bottom of some of the dots there is a calcite and manganese coating. The dots were engraved one by one. The rows are composed of 28 to 34 dots. Although the original number of dots is known, we managed to localize the start dots of rows 1 to 2 in the proximal end of the artifact. Engraved dots were touched up several times. The motion of the engraving tool is documented by striation created when the engraving tool had skidded down, and by points of removing the tool. The effect of touching up the ornament are visible in diversified cross-section. The walls between the dots are lower than the surface of the artifact. A digital mapping convinces these areas were eroded. They were extremely slender and especially sensitive to erosion. We can see with a naked eye that the dots of ornament deteriorate from row 1 to row 6. They get bigger, more amorphous, and their contours become fuzzy. This is a gradual process. Presumably, the effect of the deterioration of the engraving point. We tried to explore this problem with measurements on our digital equipment. We measured the length and the width of each dot except for those which had extremely eroded walls. The analysis of the length and width of ornamental dots confirmed the microscopic observations. Measurements of points in row 1 produced widely different values. The flint tool was still fresh and changed in parameters during the initial engraving. In rows 2 to 4, the parameters of the engraving point stabilized, but we observed the reduction of the values of minimum length and width of the ornamental dots. In row 6, we can see a degradation of the engraving point. The width of the dots increased dramatically. We produce a program of experimental research to establish some specific question. A type of engraving tool, a technique of engraving, a destruction of engraving point when walking, the dynamics of ornamentation, changes of engraving points and/or an engraver. We used pieces of reindeer antlers, mainly fragment of beam. The antler was soaked in water for 4 to 6 minutes before engraving. We started our experiment with a broken blade. At the same time, we had to reconstruct the motion of engraving point. According to our observations and preliminary engravings, we established that the dots were made by turning tool's tip repeatedly in a half-circle motion. The dots made by the broken blade were irregular. Later, we tried to use different kinds of burins with a narrow and broad edge. Some of dots were similar to original ones, but experimental dots are generally round or triangular in the outline and have more massive striations than original ones. Afterwards, we started to use a perforator and a perforator with a reverse retouch. We managed to produce very similar dots, but traces of the removing the tool were different. Anyway, we noticed that striations were produced during a very intensive half-circle motion when the engraver lost control of his tool. Later, we produced two sets of dots, each composed of 6 rows of 26 to 32 dots. The first set was produced with a perforator with a reverse retouch, the second with a perforator. Tips of experimental tools had many micro cracks. It was due to the quality of flint, the strength of motion, etc. The fractures were rather unpredictable. After cracking of the tip, the outline of dots could change. We also observed the tips of experimental tools were able to self-repair. Dots manufactured with a perforator with a reverse retouch are bigger than original dots. We should pay attention at the measurements of dots in row 15. They are diffused but not so much like in row 1 of the artifact. In rows 19 and 20, the width of dots becomes more differentiated like in row 6 in the artifact. 6 rows made with a perforator. In row 21 the widths are diffused but not like in the row 1 of the artifact. In rows 22 to 26 the measurements are very concise and present a self-repair of the engraving tip. And now the conclusions. The dots were engraved with one tool which deteriorated as work progressed, from row 1 to 6. The dots were produced by repeated semi-circular movement. The tool was probably a perforator with a tiny point. The destructions of engraving point were hardly predictable and could present very different scenarios. There is no traces which suggest changing of an engraver or an engraving tool. Research was funded by the National Science Center in Poland. Thank you for your attention.